Hey, Mike from Prep Pros here. One of the things I'm constantly tracking is the types of varieties that are showing up every single real SAT. And there's definitely a little bit of periodicity that I've noticed from when those concepts first show up on the test to when they show up again, especially with those harder varieties. So in this video, we're going to cover 10 things based on those patterns that I highly expect you're going to see on the June SAT. Now, the concepts we're going to cover on this video are going to be some of the more frequently tested concepts and also some of the more advanced concepts so we can make as great of an impact on your score as possible. And at the end of the video, I'm going to talk about some resources that helped many of my students crush the SAT in May and also can help you make some really meaningful impacts on your scores heading into June. Because so many students are now out of school or have almost no homework, we can make some serious improvements in a short time period and hopefully make it so you do not need to continue prepping for the SAT over the summer. Now, the first thing you're going to see on your SAT is a factoring question. And this is not going to be your super basic how to factor out x squared plus 5x plus 6, because the SAT knows everybody can do that. Instead, you're going to see one of two varieties, either this first variety or this second variety that looks a lot more overwhelming to most students. But the reality is there's a really amazing Desmos hack that we're going to go through that you can use to solve both of these. We're going to go through the first one by hand to start with, though, because illustrating this concept by hand is going to be really important for understanding what's happening in Desmos. So here, if we're trying to factor this down, the first thing we could do is we could factor a 3x out of all of these terms. That would leave us with 3x times x squared plus 20x plus 96. And then we could further factor this down to 3x times x plus 8 times x plus 12. And if we're really comfortable with factoring, we can do this by hand, but this often feels really difficult for students to do on the test. And since we're told one of the factors is x plus k, and we're looking for the largest possible value of k, that would tell us that 12 is going to be k. One of the things we want to understand graphically, and this is going to connect back to Desmos though, is if we were trying to find our solutions, we would set each of these factors to 0. And we would solve for x. So we'd get a solution of 0, of -8, and -12. And understanding this relationship between the two is going to be really important for essentially taking this more difficult version and being able to do it in Desmos very easily. So now we're going to connect this back to Desmos. And so all you're going to do is just graph your original expression. What you want to remember is your x-intercepts are your solutions. And we want to just remember if we see like an x-intercept of -8, that means we're going to have a factor of x plus 8, because when we set it equal to 0, we get that same intersection point. And same thing here, x plus 12 equals 0. So that's the way that in Desmos we could tell that 12 is our correct answer. We see a solution of -12, so that means we're going to have a factor of x plus 12. Now, as we go to that far more complicated example, we had 81. Now, instead of k, we're going to put in x so we can graph it. So we're going to have 81x to the 27th minus 169x to the 25th. And so these are going to be all of our solutions. So now the way that we can check if our answers are correct is when we take each of those factors and we set them equal to 0, we need to see that we're hitting at the exact same x-intercept. So if we start with our 13, now right instead of k, we're going to do x minus 9 equals 0. Now this is where you have to zoom in because this looks like it's the same x-intercept, but it's not actually the case. So you have to be very careful. College Board's a little bit sneaky with trying to catch you on these. But if we go down to C and we do 9x plus 13 equals 0, we can see we hit at that exact same intercept, and that's how we can see that C is our correct answer without having to do all of the difficult factoring. Now, the next thing you're going to see on your SAT is subject-verb agreement, and this is going to be different than your tense questions as well as some of your other rarer verb varieties, because here, if we can spot subject-verb agreement, you actually can find the correct answer without ever having to read the passage. So the really important part is making sure you can distinguish between subject-verb agreement and the other questions. And subject-verb agreement is going to have two very specific giveaways to tell you that you're looking at this. The first is you are going to see a singular and plural conjugation in the same tense. Was versus were, is versus are, run versus runs, anything like that. And your second giveaway is you're going to see 3 plural conjugations versus 1 singular conjugation, or the reverse. So the way that once you see this was versus were, you can very simply plug in he or she and they, and you're going to find an odd one out. You're going to see either only one works with these, or one doesn't work. So here we can only say he or she was. We cannot say he or she were, he or she have been, he or she are. That's how we can tell that A is correct. But we could say they are, they have been, they were. We cannot say they was. This is why you can think of this as your odd one out. If we wanted to do this a lot more technically, which I don't recommend because a lot of students make mistakes with this, you need to remove your extra information in prepositional phrases to identify which portion of the sentence is your subject. So here, however, Vikings found that another activity with an equivalency to both modern day cross-country skiing and downhill skiing, that's all prepositional phrases, this is extra information, we would reread this. Vikings found that another activity was more valuable for transporting people and parcels over long distances and hunting than for recreation. That's the more technical way we could tell A is correct, but just make sure you're looking out for spotting the subject-verb agreement and using that odd one out trick. Now, the next thing you're definitely going to see on your SAT are percent questions, and there's two varieties that I think you have an especially high percentage of seeing on your June SAT. The first variety, because so many students make a small, simple mistake and feel like they found the correct answer, is percent increase and decrease. And the second variety, which I'm going to pop on the screen here, are these more algebraic percent questions. If you want an in-depth explanation to that one to make sure you're prepared for that variety, please check out the free trial to my Ultimate SAT course. But for this variety here, the reason the SAT loves these is everybody constantly feels like they find the right answer, but they're almost always missing these. So if we're working through this question, the percent increase in population of a certain ant colony from the beginning of September to the end of November was 1,376%. If the number of ants in this colony was K at the beginning of September, which expression represents the number of ants at the end of November? The super common mistake that tons of students make is they'll pick B here. Now, if we know a very simple formula, we're going to make sure you can clean up on these questions on test day. And that's when you're doing percent increase, it's always 1 plus P. If you're doing percent decrease, it's 1 minus P. And that's percent expressed as a decimal. Now, if you don't feel really comfortable expressing percents in decimal form, which means you simply need to divide that percent by 100, we can give you a little bit more of a specific formula. You're going to do 1 plus P over 100 or 1 minus P over 100. So here, we can find the multiple very easily by simply using that formula. We're going to do 1 plus 1,376 over 100, and we're going to multiply that by K. And when we do that, we're going to find our correct answer of A. Now, the next thing you're going to see is going to lead us into another really helpful Desmos hack, especially for the more challenging varieties. And this is going to be function questions with unknown values. So for this more basic variety here, the concept we want to understand, and we may not be quite as required to use Desmos here if you feel really comfortable with your math skills, is if we're told the function f is defined by f of x equals 5/3 x plus k, where k is a constant. If f of 90 equals 120, what is the value of f of negative 30? Well, we're simply going to solve for k by plugging in 90 for x and 120 for f of x. And once we know what k is, then we can plug in negative 30 to figure out what our answer is. But we're going to go do both of these in Desmos because I'm confident you guys will be able to plug that in. But when we get to these more challenging varieties, this Desmos hack is going to become really important. Now, the function capability in Desmos is really, really powerful. So with this one here, you're simply going to type in your original function, resist the urge to add the slider, and then instead of doing f of 90 equals 120, you're going to do f of 90 tilde 120. And basically, Desmos is going to do exactly what we know we should be doing, plugging 90 in for x, 120 in for f of x to figure out what f of k is, and then you can simply do f of negative 30, and it'll give you the correct answer because it is now defined k is negative 30. So really powerful tool, but especially when we get to questions like the one below that start to feel a little bit more complex for students to solve by hand, you can actually simply just do f of k tilde negative 8k, and it's going to give you your value of k. And then if you want to get that fraction value, you simply are going to click the fraction button, and that's how we can see that B is our correct answer in seconds. Now, the next thing that I think you're going to see is a trend that I've been observing SAT test to test is a higher frequency of system of equation questions where you simply cannot use Desmos to find the correct answer. And this particular variety trips tons of students up when it shows up on the test. Here, in the given system of equations, p and q are constants, the lines of the two equations intersect at 4, y. What is the value of p? Well, this trips most students up because they're like, how am I supposed to solve this? There's 4 variables. But anytime you get tricky questions on the SAT, always try to go back to the basics of that concept. And if you remember the basics of system of equations, we can stack and eliminate to clear out variables. And what we really want to do here is we can plug the 4 in for x, so that's going to clear out the x variables. So we need to clear out the qy's. Since we have a positive 10qy, if we can create a negative 10qy, we can solve this question. So we're going to multiply the top expression by 2. This is going to leave us with 8x minus 10qy equals 72. And then we're going to have px plus 10qy is equal to 54. Now we can add these two expressions together, which is going to clear out the qy's. We now have 8x plus px is equal to 126. And now we can plug 4 in for x. This is going to give us 32 plus 4p is equal to 126. And from there, we can solve through to see that p is going to be equal to 23.5. And this is the core concept you want to watch out for if you see this variety of question on test day. Now, the next thing you're going to see on your test is exponential growth and decay. And some of these are relatively straightforward if you know the basic equation, and some of these can feel a little bit more confusing for students. And we're going to talk about a third ultra hard variety, which has shown up towards the last few questions on the second harder math module a little bit later in the video as well. But the basic concept that I see so many students also struggle with because they haven't learned it or they've forgotten it is you do need to make sure you have this formula memorized. This formula is, this is your starting or initial value, this is your rate of increase or decrease, and then it's going to be raised to your time periods. So for more straightforward questions, simply knowing that formula is going to let you find the correct answer. Two variables x and y are related such that for each increase in one of the value of x, the value of y increases by a factor of 3. This is showing us our kind of rate of increase. When x equals 0, y equals 450, that's our starting value. Which equation represents the situation? So we know we need to start with 450. Our rate of increase is 3. We can find our correct answer. Now, the other trickier variety that's been showing up on the test and giving some students problems is when they start putting in these kind of tricky portions into the exponential portion. Here we're told the doubling time for bacterial colonies on a petri dish from March 1st to May 1st is 14 days. Which of the following exponential functions models the number n of d of bacterial colonies d days after March 1st? The petri dish had 250 on March 1st. Well, we can knock off a and b with our basic understanding. We know we have to start at 250 and we're doubling. Now the part that trips most students up is the doubling time is 14 days, and that often leads them to pick this wrong answer of d. But the really simple way that you can think about these questions and get them right is you can check if this statement is true. We know it's going to double every 14 days. So if you plug d in, we need to be doubling the initial value, which was 250. Well, if we plugged d in answer choice, if we plugged 14 in for d in answer choice d, we would be doing 250 times 2 to the 14 times 14. This is going to become an absolutely enormous number. We're not going to be doubling, but when you're doubling, you're going to be raising it to the first power, and that's how you can see that C is your correct answer. So when you get these weirder time varieties of these, simply check the statement about how often it's doubling or increasing by a set percentage, and that's going to let you find the correct answer. You're almost always raising it to the first power. The next concept you're going to see on your SAT are statistics questions, but my specific prediction is going to be standard deviation questions. Now, standard deviation, very simply, is a measure of the value of spread in a data set. So if values are more closely clumped together, they're going to have a smaller standard deviation. If they're more spread out, they're going to have a greater standard deviation. For very basic standard deviation questions, range is a really good dead giveaway for standard deviation. If you have a greater range, that's going to lead you to a greater standard deviation. If you have a smaller range comparatively, that's going to give you a smaller standard deviation. But we'll sometimes get some slightly more tricky varieties where it's a little bit hard to tell what's happening. And that's what we're going to see here. So we're told the standard deviation of data set A is X, the standard deviation of data set B is Y. Which of the following statements about the standard deviations of the data sets is true? Well, what we want to notice here is in data set A and data set B, the first two values are the same. The next two values are both 2 greater than those first two. Then the next value is 2 greater than the preceding. And the final two values are 1 greater than this. So here, these values are going to be spread out in the exact same way. So the standard deviations are going to be equal to each other. The actual values don't matter. It's about the spread of the values which affects the standard deviation. Now, just so we get a little more practice with these, we're going to kind of go through a few scenarios and how it would change. Let's say we change this 6 to a 7. Standard deviation in data set B would be greater than data set A. And then same thing here, if we change this into a 5, this would be lower than data set A. So you're just looking at the spread and the positioning of the values, and that's going to let you make sure you're getting these questions correct. Now, the next concept you 100% are going to see on your SAT is sentence structure questions. These are testing your ability to identify independent clauses, dependent clauses, and phrases, and understand the punctuation that has to be used to join them. This often shows up 3 or 4 times on any given SAT, so this gives you a huge place you can improve your score. And most students are currently doing these based off of what feels right or sounds right, and they end up getting tripped up by the SAT. So learning these rules, super, super important. And you're going to be able to spot this because here we see one of those marks of punctuation that could join 2 full sentences. That's kind of our heads up that we're dealing with this. Here in 2023, acclaimed English director Carrie Cracknell modernized the classical 4-act storage of George Bizet's Carmen. Well, all the way up to Carmen, we have an independent clause. Now we'll look at what comes after. With a staging that could not be more relevant today, this is what I classify as an introductory phrase. Cracknell explores themes of gendered violence, abusive labor structures, and the desire to break through societal boundaries. This is another independent clause. Since we have 2 independent clauses, we have to use the period to join the 2 of them together. Now, if you're not familiar with independent and dependent and the punctuation that can join them, please check out the free trial to my Ultimate SAT course. There's truly no credit cards needed. It's 100% free. You're going to get super in-depth lessons around this, along with system of equations, get more practice with some of those varieties like the one we looked at earlier, and you can check out some super advanced questions that have been showing up towards the end of the second harder of module of SAT Math, such as this one, which is the hardest variety of exponential growth and decay that I've seen tested on the SAT. Now we're going to wrap up the video with 2 really advanced topics, and the first of which is going to be those advanced, challenging scientific questions that you're going to see in about 11 to 15 on the second harder reading and writing module. And these have been really hard for students because there's only a few of these across the entirety of the Blue Book practice tests, and they're showing up in really high frequency on the real SAT. So we're going to take a look at an example from one of our practice tests. So the general strategy you want to use here is on your first read, just try to orient what's happening. You're going to find what we're supporting or weakening, and then we need to see how that relates back to the rest of the text. So we want to take shorthand notes so we don't get overwhelmed by all these scientific terms. So go ahead and pause the video and see if you can work through this one. So here our conclusion is that net CH4 is going to increase as more forest is converted into pastures. So essentially what we want to see is right, the CH4 is going up. So what this now tells me is this kind of provides a filtering statement as I go back through the passage. I want to identify what is affecting CH4, what's increasing it, what's decreasing it. So as I work through all these answer choices, I don't have to just keep rereading over and over. And what we can see is we're facilitating an increase in methanogenesis, a form of anaerobic respiration that generates methane gas. So all I would think here is I'd do, okay, methanogenesis increases. That means our CH4 is also going to increase. These 2 things are positively correlated. But we also are potentially facilitating increased absorption of this through proliferation of methanotrophs. So what we now want to think about is if we have more methanotrophs, that's going to lead us to a reduction in CH4. So if we want to increase the CH4, we want more methanogenesis, but we do not want more methanotrophs. We want less of it because it's currently absorbing the CH4. If we can track that, we can see that C is our correct answer quite comfortably. Conversion of Amazonian forest into pastures changes microbial communities in soil, resulting in a greater proportion of microbes undergoing methanogenesis and reducing the proportion of methanotrophs. That's 100% supporting our answer. If you want more practice with questions like these and practice tests that are truly reflective of the difficulty and the varieties of questions you're going to see on test day, check out our practice tests. You can check out our first practice test for only $10 with the coupon code PREP10. Now, the last thing you're going to see on your June SAT are varieties of questions in 17 to 22 that look nearly impossible to solve at first glance. But the reality is most of these questions are far simpler than they appear. We just need to have effective strategies around approaching them. And what makes these questions so difficult for most students is they've never seen varieties like these before. So when they see them on the SAT, they're trying to figure everything out on the fly. So we're going to talk through a really important principle around these and where you can also get a lot more practice with these. So go ahead and pause the video and see if you can figure this one out. And also make sure you stick around for the end of the video because I'm going to talk about some resources and recommendations to help you improve for your SAT, because the June SAT is a unique school year SAT because so many students are basically done with school or they have almost no assignments where they can make a ton of progress in a week or two. Now, the general strategy that you can apply to many of these questions is if you're looking at these and you're freezing up, go back to the basics. The basics always rule everything in math. So here we're looking at functions. So if I asked you for g of 397 for a very simple function, most of you probably know just instinctually, oh, I just need to plug that in for x. So if you look at a question like this, and even though there's all these variables and it looks nearly impossible, go back to the basics. So we're simply going to plug 397 in for x and the negative 371. When we do that, we're going to get that g of, we'll do this so it's easier to follow, g of 397 will be equal to k times 397 minus 13. It's going to give us 384 squared minus 47 times the absolute value of 384 plus m. And now we're going to do the same with g of negative 371. Well, what happens when we do this is we get negative 384 absolute value squared minus 47 absolute value of negative 384 plus m. And well, if we remember the basics of absolute value, everything becomes positive, so these two equations are really just the same. G of 397 is equal to g of negative 371. Therefore, we also know that A is equal to B. Well, anything minus itself is always 0, and anything to the 0 power is 1. So this is really just the same as 43 plus 371, because this to the 0 and this to the 0 are both equal to 1, and that will give us our correct answer of 414. Not nearly as awful as it looks, but if you haven't been exposed to these varieties or aren't familiar with some strategies around solving stuff like this, it can feel really impossible on test day. So we're going to talk through some resource recommendations. Then if you guys have any questions, please drop them in the comments. Now, if you are just looking to get exposed to a ton of the varieties of advanced math questions that you can see towards the end of second module, I strongly recommend checking out our advanced math courses. We have 2 of these, there's 150 questions in each, and they've worked wonders for tons of students for helping them move from being stuck in the low or mid 700s or high 600s to pushing their scores into that 780 to 800 zone. Now, if you are just watching this and you just have a few days before your June SAT, you're trying to cram in all of the super simple, easy to improve concepts, strongly recommend checking out our SAT crash course. But for those of you who have a lot more time on your hands with the June SAT, my best recommendation would be to sign up for 1 month of our Ultimate SAT course. This is going to give you access to 7 practice tests. You're going to get access to one of our advanced math courses, our reading course, writing course, and math course. This is over 80 hours of content. This is really going to let you make enormous improvements heading into your test. If you've just burned through all of the Blue Book practice tests, and you're looking for more practice tests that are truly reflective of the difficulty of what you're going to see on test day, we do also have our practice tests available for purchase outside of our Ultimate SAT course. But the best value in how I can help you best improve is just going to be signing up for a month of the Ultimate SAT course. And like I said, you're going to get a bunch of practice tests. You're going to get to access some of the advanced math course. we're really going to help you improve overall and fill in as many gaps as possible. If you guys have any questions around anything in this video or anything else heading into your June SAT, feel free to drop them in the comments below.